All right, welcome to Physics Essentials video 3.4. We're going to learn about energy basics. So here's your objectives. By the end of this video, you should understand what factors affect kinetic energy of an object. You should be able to rank objects from the least amount of kinetic energy to the most amount of kinetic energy. You should be able to name the different types of potential energy. You should understand what factors affect the gravitational potential energy of an object, and you should be able to rank objects from the least gravitational potential energy to the most gravitational potential energy. So there you go. Kaboom. Kinetic energy. Kinetic energy is the energy of a moving object. Any object that has energy, any object that is moving automatically has kinetic energy, and any object that is not moving automatically has no kinetic energy. All right, it turns out that the kinetic energy of an object depends on two things. It depends on the velocity of the object. Basically, the faster the object is going, the more kinetic energy it's got. It also depends on the mass of the object. An object with more mass is going to have more kinetic energy. All right, keep in mind it has to be moving. All right, so with that in mind, let's do this. So let's do some examples here. So we've got Albert the mouse, who's got a mass of 1 kilogram, and Bob the dog, who's got a mass of 3 kilograms, and they're going to go for a walk together. All right, since they're both moving, they're both going to have kinetic energy, right? However, since Bob has more mass, he's going to have more kinetic energy. Okay, that gets back to this idea. More mass means more kinetic energy, right? So here, Bob has more mass than Albert, since they're presumably walking at the same speed, since they're walking together. More mass is going to mean more kinetic energy, okay? Now, Carl the mouse, for whatever reason, goes running past Albert and Bob. All right, and since he's got the same amount of mass as Albert, but he's moving faster than Albert, he's going to have more kinetic energy than Albert does. All right, so right now, sorry, so we're good there. All right, now comparing Carl and Bob is a little bit more difficult, okay, because Carl's got more velocity, right, because he's running, so he's going faster than Bob, but Bob has more mass. All right, so at this point, remember, kinetic energy depends on both mass and velocity. Carl's got more velocity, Bob's got more mass, so it's tough to say. And it says right here that unless we knew the exact velocities of the two objects, we can't really say who's got more kinetic energy. All right. Finally, it is worth noticing that if Albert, Bob, and Carl all stop, then none of them are going to have any kinetic energy, right? Because remember, you have to be moving to have kinetic energy. Okay. So there you go. Now, second type of energy that you need to know about is what's called potential energy. Potential energy is energy that an object has stored or saved. And an easy way to identify whether or not an object has potential energy is to kind of ask yourself, is it possible for this energy to be converted into kinetic energy? All right, and that'll be easier as we do the 4 types here. So there are 4 types of potential energy. All right, the 4th one here is the one that we're actually going to focus on the most. But weirdly, I think that the first 3 are the ones that are easier to visualize. Okay, so that is why we're going to start with those. So here we go. The first type of potential energy I want to talk about is what's called elastic potential energy. All right, I'm going to abbreviate it EPE. These are my abbreviations. You won't see those abbreviations in most books. But so EPE is elastic potential energy. This is energy that an elasticy or sort of stretchy object has because it's either stretched or smooshed. All right. I hope you're okay with my sort of casual definitions here. All right. So examples of things that would have elastic potential energy would be a stretched rubber band, okay, or a stretched slinky. Okay. Those are both examples of objects that have elastic potential energy. An easy way to see it is down here. Remember, in each of those cases, if you release the object, if you let go of your stretched rubber band, it's going to go flying, right? And since it's now moving, it's going to have kinetic energy. So as long as your elastic potential energy can be released and cause the object to move, then it'll have kinetic energy. That's a good sign that it had elastic potential energy at the beginning. All right. So a stretched slinky has elastic potential energy. Remember, sometimes springs can get like smushed instead of stretched, right? Like a spring in a pogo stick, for example, gets smushed instead of stretched, right? So when you smush that spring, it has elastic potential energy. An inflated balloon has elastic potential energy, right? Because it's stretched out. When you let go of it, it makes the balloon move, right? Because it pushes air out. Air pushes the balloon forward. Okay. And then I've got that Nerf gun in my classroom, right? That when you sort of cock it, it stretches a spring out. And then when you pull the trigger, it releases that energy and makes the dart go, right? So you're converting the elastic potential energy of the spring inside the gun and converting it to kinetic energy of the little rubber dart thing. Okay? So there we go. Elastic potential energy is energy that an object has because it's either stretched or smooshed and it sort of wants to return back to its original shape. All right, the next type of potential energy is what I'm going to call ZPE, which is electric potential energy. I didn't use EPE again because we already have elastic. So I used a Z because it looks like a lightning bolt and makes me think of zapping something, which makes me think of electricity. So there you go, ZPE, electric potential energy, is energy stored in a battery or other power source. So examples would be a battery, or like sometimes you'll acquire static electricity, you know, either on your sweater or your socks or whatever. So that's electric potential energy. And that electric energy can be used, you know, if you put a battery in a toy car, it makes the car go, right? So you're converting electric potential energy into the kinetic energy of the toy car. Okay. Third type of potential energy we're going to talk about is called chemical potential energy, CPE. This is energy stored in the chemical makeup of an object. Easiest example would be gasoline, right? You put gasoline in your car, you're putting energy in your car, right? And you burn it, and it turns it into kinetic energy to make the car go, right? Another example would be food, right? You eat breakfast in the morning to give you energy to get through the day so that you can, you know, run around and whatever, learn and think and move and do the stuff you got to do. All right? So those are, I think, sort of the three sort of easiest examples of potential energy. I think it's the easiest to see that that's stored energy, right? It makes sense that gas or battery stores energy, and even a stretched rubber band makes sense to me. This last example is the one that seems the least intuitive, but it's the one that's almost the most important in physics, and it's what's called gravitational potential energy. Okay, so 99% of the time we talk about potential energy in this class, this is what we're going to be talking about, is gravitational potential energy. And this is energy that an object has stored because it's elevated or being held up above some lower point. All right, so as long as the object is sort of raised up or elevated in some fashion, it's going to have gravitational potential energy. So a painter standing on a ladder has gravitational potential energy because if he takes a false step, then he falls all the way down, right? Now he's got kinetic energy while he's falling until he hits the ground. A skydiver is kind of a more extreme example of the same thing. A skier at the top of a hill, right? Because he has potential to go down the hill, right? A rock at the top of a cliff would be another one, right? So in all of those cases, if you release the object, it's going to move, right? And as it moves down, that GPE becomes less and less because it loses height. As it loses height, it gains velocity, and so it gains kinetic energy, right? So all you're doing is converting one type of energy to another. Okay. So I'm going to talk about this a little bit more. Gravitational potential energy, like I said, is the one we're going to use the most. So we should learn a little more about it. So as a reminder, any object that is elevated or lifted up or raised up somehow has some GPE, gravitational potential energy. And any object that is at its lowest possible point, a skier at the bottom of a hill, a painter at the bottom of the ladder, a rock at the bottom of a cliff, is going to have no gravitational potential energy. All right. Now, an object's gravitational potential energy depends on two things. It depends on the height of the object, how high it's elevated, how high up it is. And the higher it is, the more, the more GPE it's going to have. Sorry, that's a typo there. And then similarly, the mass is also going to affect the GPE that it has. Okay, so the higher up it is and the more mass it has, the more GPE it has. All right, so let's do another example. We're going to revisit Albert, Bob, and Carl. So Albert the mouse and Bob the dog are done with their walk together. Now they are sitting on a rooftop together. Perhaps they're watching the stars or something. All right, since they're both elevated, they're both up high on a rooftop, they've both got gravitational potential energy, right? Okay, but because Bob has more mass, he's going to have more gravitational potential energy. All right, now Carl the mouse has got a hot air balloon, and he floats right up past him, and he goes up above Albert and Bob. All right, so since Albert and Carl have the same mass, they're both 1 kilogram. Since Carl is higher up, he's going to have more gravitational potential energy, right? Because the height matters. Now, once again, comparing Carl and Bob is going to be tough because Carl is higher up, but Bob's got more mass. And so again, unless we knew some more information, in this case, the exact height of the two animals, we can't really say who's got more gravitational potential energy. Please remember, you have to have height. So if Albert, Bob, and Carl all return to the ground, then none of them have any gravitational potential energy. Okay? 2 other quick things for you. First of all, an object can have more than one type of energy. All right? The simplest example would be this. After you drop a ball before it hits the ground. So in other words, let me do this. Here's a ball. Here's the ground, right? And you're going to drop it. Whoops, so it's falling down, right? So the idea is when the ball gets to, for example, right here, it's moving, it's got velocity, so it's going to have kinetic energy, but it's also got height, right? Because it's not on the ground yet, right? And so it's also going to have gravitational potential energy. Okay, so there's an example. This ball, when it's halfway down, has both kinetic and gravitational potential energy. It's got 2 types of energy. It's got velocity, so it has Ke. It's got height, so it has GPE. All right? And then the second example, technically speaking, a flying airplane has all the types of energy that are listed in this video. It's got kinetic energy, gravitational potential energy, elastic potential energy, chemical potential energy, what did I skip? Electric potential energy. I think that's all of them, right? So see if you can tell me why it has each of those 5 types of energy. All right? And then the final thing I need to tell you is this. I did not remember to type it, so I'm going to write it right now. Units. Energy is going to be measured in joules. So although we're not going to actually learn how to calculate them, if we did calculate kinetic energy or elastic potential energy or any kind of potential energy, our answer would come out in joules. All right, so you can say that ball is being held up. It has 10 joules of gravitational potential energy. Or that jogging moose has 500 joules of kinetic energy, or whatever. All right, so energy is going to be measured in joules. All right, not super important on this assignment, but that will be very important in the next video when we learn about conservation of energy. All right, so there you go. Happy videoing. Please make sure you've taken good notes and have everything written down and categorized and organized and whatnot. All right, have a good day.